Then okay, NDTV. Okay, let us take NDTV. Now NDTV. Now all these channels are telecasting the same program at the same time. Yes or no? Yes, sir. All programs, all the TV channel, all these three channels are telecasting the same channel, same program. No, correct, right? So it is a different program, different channel, and everything. Now let us take Star Sports. Now, Star Sports have any different types of languages we have? How many number of channels we have Star Sports? We have Star Sport English, we have Star Sports Hindi, we have Star Sports Kannada, Tamil, Telugu, whatever it is, yes. But these people are telecasting all the, I mean, the program is same, right? Is the program is same? Yes. What is the difference? The only difference is the language, correct? Now, for that, we'll just write a scripting. That's it. We'll script a scripting and put it in the library. Now, all these three channels running in the same program, running the same program, only the language. For that, I'll put a library or a script. Automatically, it will get translated. Now, for this, we are taking only one OS. You see, one server. But here, all are different channels, so we will have different servers. Full server is required for all these things, but the passports no need of full server. So one server is enough. On top of this one server, I can run the applications. Now it's like your train engine pulling all the compartments, and this OS is your platform. This OS is your platform. Like engines will pull na. So I think this is a Docker engine. Docker engine will carry all these applications containers on top of it, and it's pulling on top of your OS, that is your server. Hypervisor is the visualization, that is single OS, multiple systems. Single OS, multiple systems. So single OS is the, that is host server, which is able to support your applications, you can able to see. So this hypervisor and host operating system is our AWS control. Physical service also on the AWS control. So is it reducing our charges actually? Instead of going for a full physical server, whatever the charge, it is reducing the charge by half, and that too by sending only, see, 3 is to 1. That's what I told you. One server is equal to 3 tablets. I told you, I explained you in the beginning of this compute. So I asked you guys also, which one will be faster? Your computer will be faster or your tablet will be faster? If you want to start your computer and stop your computer. But due to heavy workload, when you have a heavy workload, you go for instance. If you have very short workload, you go for containers. Are you getting this? Can you put a thumbs up symbol? So we'll go to the next one. Okay. Next, Kubernetes. What? Kubernetes. What is this Kubernetes? As a symbol itself says, what does the symbol look like? What does the symbol look like? What does this logo look like? What does this logo look like? Okay, I usually will not reply. Help. Okay, steering wheel of a ship. Yes. Now same thing, steering wheel of a ship. Now this Kubernetes is nothing but like the captain of the ship. What? Captain of the ship. What is the main job of the captain? When some storm comes, What he will do? He will jump and run. He will jump and run away. That's what the captain will do. Okay. What he will do? He will save the passengers. Yes. He will try to save the passengers. Whether he is saving or not, that we don't know. But he will try to save the passengers. Same thing here. This Kubernetes is a container orchestration tool. Orchestration. What does this orchestration means? Management. What? Management. So he will manage the containers. He will manage the containers. What is this container management? Managing the containers, correct? Now, as I told you, the captain of the ship's duty is what? He has to make sure that the customers are dropping in their location safely, correct? Same thing here. The Kubernetes mainly take care of the containers. He'll make sure that it is getting delivered to the right place at the right time. For example, let us take this ship. Let us take this ship from India. It is going to US. From India, the ship is going to US. Now this ship from India, it is going to the US. Will it go directly to the US or it will stop somewhere? Will it go directly to the US or it will be stopping in between? If you see the map, you will understand. Hmm. From India, where it will go? To the US? Will it go directly or will it stop in between? Through Indian Ocean only it has to go. Correct? Yes or no, guys? Stop in between. Okay. Now where and all it will stop? Maybe it will stop in Africa, Cape Town, and again in North America. I'm sorry, South America, and then it will go to North America. Right? So 2 to 3 places it will stop. If you go to the Indian way, the other way is no other way, so it will not be able to go. This is the only way. Now this guy is going to India, so in between it has to the Africa. Now all the containers will be delivered to the US or they will deliver the containers to Africa also. Africa also it will go, it will deliver. Will they deliver it to Africa also? No, they will not deliver anything to Africa. They are going on that way. Okay. So whenever you see this, the shopping centers and everything, you can able to see this transport. So when they're coming from one place to another place, in between there are other places also there. There also they will deliver items, they will take items. So same thing, it will deliver these containers, some containers in Africa which was supposed to deliver in Africa, then take some containers which are supposed to be delivered to US or India, it will take it in the container. Now when you are transferring all these things, who will manage these containers? That's called this Kubernetes called container management service. Okay, now what is his main job is like how the captain of the ship itself normally in a ship captain's work is to safeguard the passengers until they get down from the ship, but after that whether they go to their home or not we don't know, correct now. But here the containers, what's this thing, he has to manage the containers, it has to make sure it has to deliver to the right place, right person and right time. So now this is what here also will be happening. It will this Kubernetes make sure all the containers are delivered to the right person at the right time, and it is monitoring also. It will monitor whether it is going there to the proper location and it is working or not. Okay, till this it will check. That's what this Kubernetes is. Kubernetes is container orchestration. So Kubernetes is the Greek word for helmsman or a captain of a ship. As you said, helmsman or a captain of a ship. Now Kubernetes, the symbol as it's already denoting the steering of a ship. We can also call this Kubernetes as K8s. That is nothing. There are 8 letters in between this K and S. That's what K8 is. Next, what is Kubernetes? Kubernetes is a container management orchestration tool. Orchestration means management, I told you. It is developed by Google Lab and later it was donated to CNCF. That is Cloud Native Computational Foundation, Computing Foundation. So it's an open source. Open source means anyone can able to use it. It was written on the Go language and also called as K8s. Now there are other container management tool also. That is your Elastic. That is your Kubernetes, Docker Swarm, Apache Mesos, and EC2. EC2 is AWS EC2. That is also do the same thing. Container management tool. So it's an engine automates deploying, scaling, managing containerized application on a group of servers. On a group of servers, it will be able to manage. So container managing containerized application on a group of servers. So you can write, if you want, you can write this definition. Container orchestration tool or engine that automates deploying, scaling, and managing containerizing application on a group of servers. On a group of servers. You have written. Okay. Now Kubernetes. So Kubernetes, you can able to see it can able to deploy, scheduling, scaling, load balancing, all those things you can able to do. As we already mentioned, it is container management tool. It manages all the containerized applications also, and the applications available on a container platform like Docker. Now we will make sure that ensure that all the load balancing, all the balance load is balanced, and it is scale up and down based on the user load. Based on the user load, it will scale up and down. Now what Kubernetes do? This is the main thing you can able to see EC2. So it can able to deploy, it can able to schedule, scaling, load balancing, batch execution, rollbacks, monitoring. All these tasks you can able to done by Kubernetes itself. That's why they have separate certification for Kubernetes also. It will take care of the end-to-end DevOps things, everything it will be able to take it. So apart from this Kubernetes, we have the same procedure will be followed in Docker Swarm and Apache Mesos Marathon and EC2 instance and EC2, I'm sorry, ECS, Elastic Container Service. Okay. So all these things, that means for your applications, it has to be deployed, it has to be scheduled, it has to be scaled when the workload is more, it has to balance the workload also. Batch execution, if in case it's a batch execution, it has to go with batch execution and it will roll backs and monitoring also. So what is Kubernetes? As I already mentioned, it's an open source software container orchestration. It deploy and manage containerized application at scale. Containerized application means we can able to see it is contained and we can able to scale at any level. The same toolset can be used on premises and in the cloud also. Next, complements Docker. So Docker enables you to run multiple containers on a single OS host. Docker only allowing you to run multiple containers on a single OS host. So Kubernetes orchestrates multiple Docker hosts, nodes, and automates. So container provisioning, networking, and load distribution and scaling also will be able to do by Kubernetes. So container provisioning means you can able to add multiple containers when the application is required. Even if the container get crashed also, it will Kubernetes will automatically take one more container and make sure that your application is running. Your application is running. So it will distribute the load, networking and scaling also. Same thing is for applied for ECS also. ECS is nothing but the same. Like Kubernetes, we have ECS, which is AWS performance. So AWS will have the same service, Elastic Container Service, which is highly scalable, fast, and container management service. Now, key benefits. It orchestrates the running of Docker containers, maintains and scales a fleet of nodes that run your containers, and removes the complexity of standing up the infrastructure. That means it can able to remove the complexity, it can able to run this application by itself, it can able to manage nodes. Fleet of nodes means multiple containers, multiple servers it can able to manage. So same thing only you can able to see elastic balancing, security groups, EBS volume and IAM rules. It is can able to integrate with your EC2 also. That's what elastic container service. Now Elastic Container Service has two options. One is you can able to run the cluster backup by EC2 instance. You see backup by EC2 instance where you have to manage the Docker engine, VM global guest operating system, API application and Bean libraries also. But when you take Elastic ECS cluster backed up by Fargate. Fargate is a serverless service. As we already mentioned, serverless means what? AWS will manage most of the things. You just have to say, I mean, you just have to focus on your application alone. So here you see, if you use Fargate as an option, you manage the application and AWS will manage the remaining infrastructure and everything. So Amazon ECS when we go, taking the Fargate as the option is the best option. Next, EKS. What is this EKS? EKS is mentioned by EKS is mainly created by AWS for those who are working in Kubernetes. That means, those, for example, those who worked in Windows and suddenly if they ask you to use Linux or Mac, will they able to work properly? Will they able to work properly? They will not feel comfortable, correct? Na? So they will be comfortable in Windows. Now, same thing only those who are already worked in Kubernetes, they will not be comfortable in AWS. So AWS itself is creating a service called EKS, which will support most of the features of Kubernetes and support help. You see, it enables you to run your Kubernetes on AWS and certified Kubernetes conference supports all the migration also. You've already done all the project in Kubernetes and you want to move to AWS, then EKS is the best option. It supports Linux, Windows containers compatible with Kubernetes community tools, supports and popular Kubernetes add-ons. Used to use Amazon EKS to manage clusters of Amazon EC2 compute service instances. So run containers that are orchestrated by Kubernetes on those instances. So we can able to run containers that are orchestrated by Kubernetes on those instances also. The same thing only. EKS, EKS, ECS, and Kubernetes all are same services only. We can able to run all the clusters, compilers, nodes, everything, and managed by Kubernetes. Next, ECR. ECR is another service. ECR is like your GitHub, where you store all the Docker images, mainly to store, manage, and deploy the Docker container images. Deploy the Docker container images. Whatever we want to store, we can able to store it in the ECR, that all the images as live, and from that live we can able to use it to launch an instance. Launch an instance or launch a container, we can able to launch it. But the copy, like in your EC2 instance, we learned about AMI, right? That AMI is a template which is having the copy. The same template we are able to use it here. We can able to same like template how AMI is creating templates. Same thing ECR is keeping all the template images here, but it's like your main one, like uh, like your buses. So if your new buses come to the town, where it will go first? Where it will go first? They have launched, the government has launched a new bus first day. Where it will go first? Taking from the showroom. Depot, correct. Why depot? Because in case if it is having anything, for example, it is going from the depot, and what it's going to do, it's going to register, this is my bus, and this is my number plate, and which route I'm going to travel, all these information, who is the driver, who is the conductor, everything it will write. Why? Because in case if there is any repair in the middle of the road, they have to contact the depot first, correct now, for help. Same thing, all your images will get stored in the ECR, and that from that ECR we will take and use it whenever we want. Okay, but first copy should be stored in there so that we can store, manage, and deploy. So ECS integration, Docker support, team collaboration, access control, and third party integration also we can able to do it. Coming to the end of this section, can anyone read this? Yes, Tanish, can you read it? Okay, Kiran, can you read it?
Yes, sir. Container can hold everything that an application needs to run. Docker is a software platform that packages software into containers. A single application can span multiple containers. Amazon Elastic Container Service orchestrates the running of Docker containers. Kubernetes is a source software for container orchestration. Amazon Elastic Kubernetes Service enables you to run Kubernetes on AWS. Amazon Elastic Container Registry enables you to store, manage, and deploy your Docker containers.
Okay. Now introduction to Lambda. So Lambda, as I already told you, it is a serverless service. It is a serverless compute service. Serverless means everything managed by AWS. You just focus on your application alone. Now here you can able to see Lambda. Lambda is a serverless compute service. First point. Lambda run your code without servers. Without servers means server you are not maintaining, so we are mentioning as servers without servers. First, our job is upload your code. Then we write the code you run as a Lambda function that we can able to run it as an AWS service, or it can be a mobile application, or it can be a website also. That what HTTP endpoints, right? Our job is first upload the code, run your code on a schedule basis. Run your code on a schedule basis either. For example, Lambda having two options. Lambda have two options. Run your code on a schedule basis or in response to events or in response to events. One is schedule means like for 5 o'clock we want to use it. Only 5 o'clock I want to run a code. Let us take a JavaScript function. Whenever you click the submit button, what is happening? You are able to see whenever you click the submit button, what you are able to see? You are able to see that thank you button is coming, thank you is coming, right? So how it is getting triggered? Because a function you have written the code, you have written the code there, correct? So based on the code, when you click that, it is happening. That's called events. That is when you click the button, the code is running. That is event. Another one is code on schedule. That is you already written a script like your alarms. Your alarm is coming at 6 o'clock. Automatically, it is coming in front of you because you have scheduled it at 6 o'clock. Same thing we can able to use this lambda function as schedule basis or event basis. Your job is to just to run your code, run only when it is triggered, and you're going to pay only for the compute time that you use. So you're going to pay only for what the time we used. So write this 5 6, write all these 6 lines. Your code will run only when it is triggered, and you're going to pay only for the compute time that we use. Write these 6 points, and I'll explain you in depth. That means in depth in sense, just it's already the concept is correct. The concept is you can able to see what is first step, second step, third, fourth, fifth. Once you're done, just put a thumbs up symbol. You're done? Yes? Okay. Now, now, Lambda will support all multiple languages. I told you JavaScript, correct? So JavaScript. It's not only JavaScript. It will support all the multiple languages: C, C++, Java, Python, everything it will support. Mainly, we'll be using completely automated administration. We go for this Lambda function. By default, it is built-in fault tolerance. That is, like in your VS Code, it will show you errors, right? Whatever mistake is happening, it show error. W like the underline will be there, na? Like red underline will be there. Same thing it will show here also. Next, it supports the orchestration of multiple functions. It supports the orchestration of multiple functions also it will help. Next, pay per use pricing. We are going to pay for what we use. We are going to pay for what we use alone. So that's are the main benefits of Lambda function. Now how it works, let us see. You see, it'll event source. So we can able to configure this Lambda function with other event services, AWS services also. So we can through that we can able to invoke the Lambda function by using AWS SDK, that is software development kit, or ACLI also. So for example, S3 or DynamoDB or SNS, SQS, API gateway, load balancer, all these things we can able to connect it to the Lambda function. Now this Lambda function can be invoked. Lambda function can be invoked when, for example, if you are scheduled at 6 o'clock, then it will be like CloudWatch alarm. The CloudWatch metrics it has to meet. If it reaches the metrics, it has to trigger a event. For that, you can have this running of your code only when it is triggered. So through Lambda function, it will come to, through AWS, through S3 bucket, it is coming to Lambda. Then from Lambda will trigger based on the CloudWatch monitoring, and it will run and trigger. Now the best examples you can able to see. So Lambda function configuration, how we are going to configure this. First we mention the configuration code, all the dependency files, everything. Assign an execution role, like a temporary role, IAM role, and assign it to the Lambda function. Now the Lambda function based on the metrics and log monitoring, it will run and trigger the code. Okay, so we have to upload the code with the dependencies and assign the permission for the Lambda to access the resource, and then it will trigger on time as per mentioned for the schedule. It's called your Lambda function configuration. Now for easy understanding, you see, as I told you, two types of the scheduling are there in Lambda. One is scheduled based, another one is event. Scheduled means what? For example, you are in office, you want to go to office, and every 6 p.m. the system has to be shut down. Correct? When you're coming out of the office, you have to shut down your systems. But you usually forget. So what we can do, we can put a configuration settings there. We are setting in the CloudWatch that, you see, in the CloudWatch we set the time as 6 p.m. We are writing a Lambda function. We are writing a code Lambda function, and we are assigning a role also. We are assigning a role also. That role represents, it is has to go and access the EC2. It has to go and access the EC2, because as I told you, even one service to another service wants to access inside the AWS, it needs permission. It needs permission. This permission has to be given in this IAM role. From that, it will trigger. From that, Lambda function will get trigger and stop the instance. Stop the instance means stop the server at 6 p.m. So you don't want to do thing, it is automatically going to do, because we have scheduled it. That's what scheduled based Lambda function. Lambda function is serverless function. That means you don't want to maintain anything. When you put the code will run automatically and do it. Now same thing I can able to start the system also I can do. So here CloudWatch, I set the alarm as 9 a.m. Alarm Lambda function has returned and IAM permission has been given to access the EC2 instance. We are mentioning start at 9 a.m. So automatically the computer is getting started. So imagine you are going to office at 10 o'clock, or you want your login time is 9:30. Automatically the system has to be logged in. If only system logging is your attendance means, we can able to set this automatically and it will do it by itself. That is what schedule based instance, schedule based Lambda function. Next one is event based Lambda function. Event based Lambda function is when some event happens. For example, a user is pasting a 5 MB photo. Like for example, when you apply for government jobs, they will ask you to reduce the size of your photo from 5 MB to 50 KB, right? So how will you convert this? You just go and upload that file in an online converter. You will convert and reduce it, correct? Now how it is happening in the backend? Let us see. So this 5 MB file you are uploading, first it will go to the source bucket, that is S3 bucket, storage bucket. We put that in the source bucket. From there it will go to Lambda, where Lambda we have written the function that you pull the image from this bucket. Whenever somebody puts some image, it will immediately pull. For that we have created a role. We have created a role and we have given the permission to Lambda, that Lambda can able to access S3 bucket. That permission we have written. Now again one more Lambda function we have written, that it has to take that image which is pulled as to get converted into res, that is 50 KB, and put it inside this another bucket called target bucket. That is source bucket, this is target bucket. For that, we return the permission for Lambda and we are given the execution role automatically. It will be able to access S3 bucket. So now you will be able to get that photo immediately. How it is happening? Within 1 minute, it will be happen. Not even 1 minute. Within a fraction of seconds, it will work. I think you might have converted this online image converter and all, right? Online image converter to reduce size. So here you can able to see reduce online converter is there now. So now this is the bucket. When you select some image, this will go and store it in the bucket. This will get stored in the bucket. So let us say I am just put an image, nice JPEG image. Now convert this size. Now convert this size we are mentioning and resize image. That's the button. So until we upload here, it is going to the S3 bucket. Once you click converted, immediately it will go to the S3 bucket. Image has been resized. That's it. 1 second. You see what is the size previously? Previously it was a bigger size. That was 209 KB. It was. Now it has been converted into some less KB. That too I didn't resize anything, right? So I have to reduce the size. I can mention percentage. I can mention 50 or 60 something. Then the quality again I mention something low. Now I just reduce it. Immediately it says, see, you see 72 kbit. So now this is the first bucket. The image is going to the first bucket, this one, and when you are outputting, output come to this target bucket. From there we are taking downloading. Here we are uploading, here we are downloading. In between this lambda function we configured, it is working in seconds. Within a fraction of second, it is converting that image. Are you getting? Yes. So what are the lambda quotas? Lambda quotas soft limits are per region is concurrent executions can go to concurrent means at the same time I can execute up to 1000 lambda and function and layer storage, that is 75 GB of storage I can able to go for a function, and hard limits for individual functions per region, all these things. So memory allocation for one conversion it can go up to 1 GB, that is what 10,240 MB. Next, function timeout. This is the main thing. The function timeout should not exceed 15 minutes. It will not go 15 minutes. Just now I showed you it converted in 1 second or 2 seconds. Correct? Na? Same thing, the lambda function will not go above 15 minutes. Next, deployment package size 250 MB unzipped including layers you can able to go. And container images can also carry up to 10 GB of sizes. That's what your lambda functions. Is Kiran, can you read it?
Yes, sir. Serverless computing enables you to build and run applications and services without provi- provisioning or managing servers. AWS Lambda is a serverless compute service that provides built in fault tolerance and automatic scaling. An event source is an AWS service or developer created application that triggers a Lambda function to run. The maximum memory allocation for a single Lambda function is 10,240 MB. The maximum runtime for a Lambda function is 15 minutes.
Okay. This is the last one. We'll finish it in 5 minutes. Okay. Introduction to Elastic Beanstalk. Elastic Beanstalk again is a serverless compute service, but the thing is, mainly it is easy way to get web applications running. So easily we can able to run the web applications, and it is taking care of full thing, everything. You see, a manager service that automatically handles infrastructure provisioning, deployment, load balancing, auto scaling, monitoring, analysis, logging. Everything will be managed by Elastic Beanstalk itself, and that too no additional charge for Elastic Beanstalk. Only we are going to pay for the resources that we use. Only the for the resources that we use alone we will be paying it. Remaining things, everything, mainly we'll be using it for AWS. I mean for web development and applications we'll be using this Elastic Beanstalk. Okay. So as it is again a serverless service, serverless service. It is taken care by everything will be taken care by AWS itself. And mainly, as I told you, it's supporting web and web applications. So it will support all the programming languages. You see, what are all the programming languages it support? Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker. Everything it support. Your job, you see, you focus on your code. Remaining things, that is launching, uploading your code, and Elastic Beanstalk will automatically handle all the deploying on servers such as Apache, Nginx, Passenger, Puma, Microsoft Internet Information Service, application server, language, interpreter, operating, hosting, everything will be managed by AWS itself. You focus on your code only. So this is the main thing. What are all the things it will support by Elastic Beanstalk? You can just write this if you want, or else I'll be sending you the document as well. Okay. Now, what are the benefits? You can see fast and simple to start using. Productivity will increase. Difficult output, that means not outside. It will not be doing anything. I mean, it will be in full control. It will be in full control. Complete resource control. Full control. It will be there. We will be having a full control with us. Coming to the end of this section, Elastic Beanstalk enhances developers' productivity, simplifies the process of deploying your applications, reduces management complexity. An Elastic Beanstalk supports Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. There are no charge for Elastic Beanstalk. We are going to pay only for the AWS resources that we use. Okay, so that's the compute service. We are coming to the end of this section. We discuss about AWS compute service, Elastic compute cloud, Elastic Beanstalk, Lambda, containerization. Now coming to the knowledge check. Which AWS service helps developers quickly deploy resources which can make use of different programming languages such as .NET and Java? What is the answer for this one? Okay, Elastic Beanstalk, Kiran said. What about others? Okay, see. Okay, we'll check the answers. The answer is C. Just now we learned na Elastic Beanstalk. Okay, fine. So we have completed the 6 modules, main modules, and 2 more main modules are there. That is storage and database. So tomorrow first we'll see one lab, that is compute lab. We'll finish the compute lab and we'll start the storage. Okay. Okay, guys. So we'll see you tomorrow at the same time. I'll send you the document.